Hello everyone, welcome to Payment Tech Media. In this video, we are going to talk about the differences between IPv4 default subnet mask versus classless subnet mask. So let's jump into my computer and take a look. So as you guys already know, in class A, B, and C, we have default subnet mask for class A 255.0.0.0, for B 255.255.0.0, and then C 255.255.255 and 0. So for class A, the default subnet mask 255.0.0.0 means the first octet it's only network bits, the rest of them it's host bits. So we have 8 bits turned on, 24 bits are turned off. In other words, for class A, we can also see this shorthand version or CIDR notation /8, and then class B /16, and class C /24. So this 255.255.255.0 means /24. This 255 in first octet pretty much means 8 ones. 255 in second octet, 8 ones. 255 in a third octet, this is a third octet, 8 ones. And if we add all these decimal values, so we get these 255, and then so that's a total of 24 ones, network bits, and then 8 host bits. Okay, so these are known as default subnet mask. Now what happens if we don't want to use default subnet mask? So that's known as using subnetting. So subnetting, it's pretty much very useful in order to be able for better manage and organize our network, not to waste too many IP addresses, and for security reasons. We will see and taking the advantage of subnetting. So, and anytime when we talk about subnetting, we have to use classless subnet mask. For example, if we use default subnet mask, and let's say if this is for class C network, we already know default subnet mask for class C, it gives us 254 available IP addresses. Let's say if we don't want to use 254, if we have a network, let's say our accounting department, it's only 16, or human resource only, let's say 8 employees, and in the sales we have only let's say 24 employees or computers, let's say we need IP addresses, but we don't want to use 254. And so it is better to use classless subnet mask, not default subnet mask. And how can we do that? It's basically by using the number of bits. For example, instead of using this default network bits, just simply borrowing from the host bits. And for example, if we, let's say, which that's also another formula depending on number of hosts or number of subnets, and we will see different values. But if we quickly go over, if we already know for class A is 8, and this 8 means we have 1, 2, 3, 4, 5, 6, 7, 8 bits already turned on, going from left to right, right? These are the network bits. And so if we add the decimal values, so 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, that's 255. Now let's say if it is, let's say 9. So we are basically borrowing 1 bit from the host, right? So now it is 1, 2, 3, 4, 5, 6, 7, 8, 9. What is our new subnet mask? So the new subnet mask would be, it looks like 19, but that's /9. Basically known as the CIDR notation, classless interdomain routing, and the CIDR. So this /9, 9 bits, network bits, 9 bits turned on, This is the 9 bits. What is our subnet mask? So subnet mask is basically just like converting this binary to decimal. So here it's only one of the bits turned on, right? So the rest of them it's off. Therefore, a subnet mask would be 255 dot this one, only this one turned on, 128, right? So 128 dot here, all the bits turned off, all the bits turned off. So 0, 0. Now let's say if this is forward slash 10. So 10 bits, right? So let's count left to right, 8 plus 2, 10. What would be the subnet mask? So the subnet mask is basically 128 plus 64 on the second octet, right? The first octet we already know, 255, all the bits turned on. So 255 dot here, 2 bits, 128 plus 64, that's 192 dot 0 dot 0. And so on, forward slash 11. So we add one more. So here, these are just one examples. If we want to use basically the CIDR classless interdomain routing instead of using the default subnet mask and just borrowing one more bits. So here we have 8, 9, 10, 11, right? So 128 plus 64 plus 32. So 128 plus 64, that's 192 plus 32, 224 on the second octet. So here 8 bits, it's on the first octet, so that's 255. When we add all the ones that already turned on, that's 255. And let's go ahead and add. Here we have 128 turned on, 64 and 32, that's 224, 0, 0. And let's go over 12. So 12, let's add one more. Here we see 8, 9, 10, 11, 12. And it gives us the first octet, of course, 255. And here should be 240 because 128 plus 64 plus 32 plus 16, that's 240. By the way, it's a table. If you remember and memorize this table quickly, you can tell what is the actual decimal value of these binary numbers, because remember, always goes from left to right and it's just borrowing by 1 bits, right? So let's go over this table. Anytime when we are borrowing 1 bit, so speaking about borrowing, we are getting this bit from the host section. So if it was class A, by default we have 8 bits, that's a network. These are 0, that's the host bits. So we are borrowing from the host bits right now. Like if we add one more, it's just borrowing one more bit from the host, from all these zeros. So usually you will see reading basically textbooks, authors, they refer to as borrowing bits, borrowing from these host bits and turning it to the network bits, which in other words, basically it will be, these are our network bits, these are the borrowed bits, our subnet bits, and the rest of the zeros is pretty much host bits. Okay, so let's go over this table. Anytime when we are borrowing 1 bit, so when we're borrowing 1 bit, always is 128. Anytime when we're borrowing 2 bits, it's 192. 3 bits, it's 224. When we borrow 4 bits, it's 240. When we borrow 5 bits, it's 248. When we borrow 6 bits, 252. When we borrow 7 bits, 254. When we borrow 8 bits, it's 255. So always keep in mind, this is the table that you need to memorize, remember, and so because always is the same. For example, let's go over, you know what, we take A, B, and C, and all of them, let's add by, let's say, you know what, let's say 5, okay, so if we add 5 bits, so if this is 8 plus 5, that should be 13, right? So forward slash, if this is class A, forward slash 13. B, 16 plus 5, so that's 21, right? So if this is B, 21. And then C, 24. 24 plus 5, so 29. So C, 29. Okay, let's see if this one, 13, what would be 13? So we have the first 8, right? That's 255, 255. And then 13, we basically added 5 more bits, correct? So 5 plus 8, that's 13. And anytime when we borrow 5 bits, 248. So it should be 248.0.0. Why? Because let's count. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is our cut line. So if we convert, and these are 0, if we convert all the ones to basically these binaries to decimal, so the ones turned on, we just need to add 128 plus 64 plus 32 because all turned on, right? Plus 16 plus 8, 4, 2, 1, that's 255. And here we have 128 plus 64 plus 32 plus 16 plus 8, so that's 248 on the second octet. You see, 5-bit borrowed because, again, A, default subnet mask is 8. Now it says 13. We know this is a classless subnet mask. It's not a default subnet mask. They borrowed 5 bits, correct? So anytime borrowed 5 bits is 248. Okay, here, class B 21. We know this is not a default subnet mask. They borrowed 5 bits, and this is basically for class B. By default already we have 255.255 dot here on the third octet, because when we add 20, it is 21, correct? So 8 plus 8, what is it? That's 16. 17, 18, 19, 20, 21. That's 5 bits, 5-bit borrowed. So we know we are on a third octet. So when we borrow 5 bits, again, same thing, 248.0. Now let's take a look at class C. Class C IP address, they gave us a CIDR notation 29, and we already know this 29, they borrowed 5 bits from the host bits because by default class C is 24. So 24 plus 5, that's 29. Therefore, the default subnet mask is 255.255.255. On the last octet, the host bits, they borrowed 5, correct? 29. Let's count. 8 plus 8, that's 16. Plus 8, that's 24. 25, 26, 27, 28, 29. They borrowed 5 bits from the host, okay? So here should be 248. That's it. You see all of them, we see 248. But of course on different octets. So that's why I talked about this one. It is very important to understand if anytime when we borrow specific amount of bits from the host, what would be the result? Always is the same. Anytime when we borrow 1, it's 128. Anytime when we borrow 2 is 192. And of course, it the only difference is just on what octet, which again, when we count, like let's say this one, 21. Let's count 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's erase this. Okay, 13, 14, 15, 16, 17, 18, 19, 20. It was 21, right? 20 and 21. So we said 21. Okay, so 8 plus 8, 16, 17, 18, 19, 20, 21. Okay, this is our cut line. And we already know 8 bits turned on, that's 255. Okay, so that's 255. And here, 8 bits all turned on. So that's again 255 on a second octet, 255 on a second octet. And then here we have only 5 bits basically turned on, borrowed, in other words. The rest of them, it's off. That's the host bits. Zeros, host bits, ones, network bits. Okay? So here, in this case, when we talk about 21, they borrowed 5 bits, so we can see on the third octet, because 8 plus 8, 16, 17, 18, 19, 20, 21. So that's on the third octet. We just write 248 on the third octet because this is on the third octet. When we convert this binary 11111000 to a decimal, it gives us 248. So again, please make sure you watch my other videos. I talked about how we can convert to binary, to decimal, and all that details I talked previously. If you haven't watched those videos, make sure you watch, and it clearly goes over how we can convert binary to decimal, decimal to binary, all that. Okay, so yeah, this is comes very handy and useful. One example, let me go ahead and give you guys one CIDR notation quickly. Let's say 19. Okay, so we know by default, for class B, 16, right? So we borrowed how many? 3. So anytime when we borrow 3, what is it? 224. On what octet? On a third octet, because 16, that's 255, 255 already, 8 plus 8, correct? So 255.255 dot, so notice 19, 3 bits borrowed on a third octet, so 224. It should be 224, and the last octet is 0. That's it. Quickly, you just converted this CIDR notation of 19 to the full version of the subnet mask. And we know this is not a default subnet mask because 255.254.0, that's not a default subnet mask. The default subnet masks we can see here for class A, 255.000, for B, 255.255.000, for class C, 255.255.255.0, and the shorthand version of how many bits it's basically turned on, how many network bits. For class A, 8 bits network bits we have. For class B, 16 bits network bits. For class C, 24 network bits. Which again, in other words, when we have these bits, binary bits converted, because it's already turned on, right? Converted to decimal, it gives us these decimal values. For 16 is 255.255.000. For 8, 255.000. And for 24, 255.255.250. Okay, so 19, the /19, again, we already know by default for class B 16, therefore 16 plus what gives us 19? 16, 17, 18, 19, 3. So looking at this table, 224 here on a third octet. 255, that's the 8 bits. 255, that's another 8 bits. So 8 plus 8, 16. So it gives us 255, and we need 3 more. So we are on a third octet, 224. And then the last octet, it's all 0. Now let's see. So here, if I erase all this, and if I go back, we have 8 plus 8, 16, 17, 18, 19. And let's draw, this is our cut line. So 0, 0, 0, 0, 0, the rest of them 0. Okay. So we have 8 plus 8, 16, 17, 18, 19. So we have only 3 bits turned on. If we convert this binary, these binary numbers 1110000 to decimal on the third octet, so it basically means that the ones already turned on, we just need to add 128 plus 64, that's 192, plus 32, 224, and that's it. So it's only these 3 numbers turned on, so we just need to add these 3 numbers. So we have 224 here on the third octet for the /19. And same applies for any other CIDR notation. If this is a /, you know what, I said 3, correct? So 8 plus 3, that's 9, 10, 11, which it gives us 255 here on this octet would be 224.00 if this is 11. And actually here we can see we already have, for example, /11, 255.224.00, where the 224, again, it's coming from when we talk about 11, we just need to count. If I erase again, let's count. If I go back, we have left to right. Let's count 11, right? Because these numbers, number of network bits turned on. So left to right, ones represent network bits, zeros represent host bits. So we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. So this is our cut line. All the rest, it's 0. Alright, so remember this is all our subnet mask, right? Subnet mask bits. And so here we have 8 plus 3, that's 11. So 8 bits turned on. If we convert this binary to decimal, we just need to add all these decimal values because all of them turned on, and it gives us 255. And here only these 3 we just need to add. So 128 plus 64 plus 32, because only these 3 turned on. 0, it's off. We don't need to add these numbers. So it gives us 224 on a second octet. And the rest of them 0 here, as we can see for the /11. So this is kind of like quick comparison when we talk about the default subnet mask. And in the default subnet mask, again, we already talked about earlier previous videos how many available IP addresses we can have in each class by using default subnet mask. But let's say sometimes we don't want to use all that IP addresses. We want to use let's say less. We don't have that many employees or that many devices on the network, and or to better manage our network, better organize, and or maybe for security reasons. So that's where the classless interdomain routing comes into play. That's where the subnetting, known as subnetting, breaking a large network into the smaller networks. So that's the subnetting comes into play. And how can we subnet network? By just simply using classless subnet mask, which simply by borrowing bits from the host bits when we talk about the subnet mask, not to use the default subnet mask. I hope this video was helpful. In the next videos, we will talk about subnetting, supernetting, so stay tuned. Thanks again for watching and have a good day.